Hi, I'm Granny, and we're going down the rabbit hole of Max Planck, or otherwise known as Max Carl Ernst Ludwig Planck. Think of quantum physics. He was a German theoretical physicist whose discovery of energy quanta won him the Nobel Prize in Physics in 1918. Energy quanta will later be known as quantum theory. Now, this is going to be a complicated one, but it's important for you to hold there and be patient because it will be revealed why I'm going down this rabbit hole. He was born in 1858 into what is described as a traditional intellectual family. His great-grandfather and grandfather were both theological professors. His father was a law professor and an uncle a judge. He loved math, music, singing, learned the piano, organ, and cello, composed songs and operas, but chose physics at the university. War was common in his life in Germany. If you were to Google during his lifetime, 1858 to 1947, most years involved wars, which I don't know what that would look like, except I've seen pictures of Germany after World War II, which was pretty devastating anyway. A famous quote of Max Planck's is, "A scientific truth does not triumph by convincing its opponents and making them see the light, but rather because its opponents eventually die and a new generation grows up that is familiar with it." And that's pretty interesting. It's kind of caustic in his attitude, but probably pretty truthful. Because I remember being on the debate team was an honor, especially if you go to different events, including the national debate event. You don't see that very often, and I think we all would benefit in the process of preparing for a debate because that preparation means that you have to create an argument pro and con, regardless of what your opinion is. Because I think we all gain by understanding another person's perspective, even though we may not agree with it. Max Planck used a thought experiment to develop his theory. He imagined that light was emitted from an object as particles instead of a wave and could not go below a certain minimum energy and needed to reach some absolute zero minimum limit on energy. One of my favorite stories about Albert Einstein was shared by one of his colleagues. He observed Einstein at a gathering after a day in school, and this was at the university. The group would often meet in the evenings to discuss ideas, experiments, experiences, and it was at one of these times that Einstein sat apart from the group doing his own thought experiment. He was observed concentrating so hard on an idea to the point that beads of sweat broke out on his face. Have you ever concentrated so hard? Have you ever been encouraged to use your brain like this? When I read this story, I was shocked, but understood Einstein just a little bit better. Planck's theory is that energy can be emitted or absorbed by physical bodies in distinct amounts, measured amounts. Think of it that way. Different atoms and molecules can emit, reflect, absorb. Think of the difference between wearing a white shirt and a black shirt on a sunny day. These amounts are called quanta or photons, and each quantum has energy that is proportional to the radiation's frequency. Think like spectrum. The proportionality, I'm still reading the quote, constant that relates the energy of a photon to its frequency is called Planck's constant. And it is fundamental universal constant, which means it's a way of measuring. Planck's constant is foundational for quantum physics, and which he used to derive a set of units called Planck units, expressed only in terms of fundamental physical constants, which is how scientists quantify, think of quantum, quantify information. Please be patient. This is huge, but there is a reason why we're going down this rabbit hole. Quantum physics is the theory that logically leads to the conclusion that everything is interrelated, and that what we see with our eyes is only a shallow outer form of a much deeper reality. What we see, remember the light spectrum, is what we think we see, but is most likely something we haven't seen before. Think of protons, atoms, electrons. Quantum physics is important because it helps us understand the behavior of nature at the atomic level and below, and how particles interact to form matter. Think of the universe. It's the foundation of many other areas of physics, including quantum chemistry, quantum field theory, quantum information science. Quantum physics has led to innovations such as lasers, LEDs, transistors, medical imaging, electron microscopes, solar cells, DVDs, cell phones, atomic clocks, GPS. Can you imagine what our daily lives would be just without one of these items? And one led to another that led to another, which is part of the quantum theory, that it's all interconnected. Quantum theory can be used to explain natural phenomena such as the color of the sky and our lakes, ocean, even photosynthesis. According to scientists, it is through quantum theory that can explain the growth of the universe, including the formation of galaxies, stars, space-time, our Earth, our solar system. It suggests that quantum fluctuations in an inflation field, you can go down that rabbit hole, caused energy to clump into matter. Think of the electromagnetism of our Earth and how that helps keep our Earth together, which eventually formed galaxies and clusters. And I want you to take the time to go to NASA's James Webb Space Telescope. And I know I've referred you to that website before because it is amazing, mind-blowing. What an adventure it is, because it's quantum physics that helps us understand what we're looking at and how our universe works. There is a phrase called the second quantum revolution that we are currently in the midst of. The first quantum revolution gave us the new rules that govern physical reality. The second quantum revolution will take these rules and use them to develop new technologies such as quantum information technology. Think of quantum computers, quantum electromechanical systems, coherent quantum electronics, quantum optics, can you imagine? Coherent matter technology. There is a quote that I will be sharing with you from the Symmetry magazine. But before I do, I need to clarify some of the terminologies that's included. Ether. According to ancient medieval sciences, ether, which is also known as the fifth element or the quintessence, is the material that fills the region of the universe beyond the terrestrial sphere. An interferometer is an instrument in which the interference of two beams of light is employed to make precise measurements. We also need to understand what the Michelson-Morley experiment was. It was an attempt to measure the motion of the Earth relative to luminiferous, light-producing ether. The experiment was performed in 1887 by American physicists Michelson and Morley at Case Western Reserve University in Cleveland, Ohio. The experiment compared the speed of light in perpendicular directions in an attempt to detect the relative motion of matter through luminiferous ether. The result was negative, but it's important to know that. The result is generally considered to be the first strong evidence against ether theories, as well as initiating the line of research that eventually led to special relativity, which means that experiment helped kind of take ether off that list to help people then focus in other areas like special relativity. Here's the quote from Symmetry magazine dated January 2022. Classical interferometers, like the type used in the famous Michelson-Morley experiment that measured the speed of light in different directions to search for signs of hypothetical ether, looked at the interference pattern of light. New matter wave interferometers exploit the principle that everything, not just light, has a wave function, which is really important. Measuring changes in the phase of atoms, which have far shorter wavelengths than light, could give unprecedented control to experiments that attempt to measure the smallest effects, like those of gravity. Why is this important? My interpretation of this is technology is getting to the place where our devices will be sensitive enough to rate, gauge, measure gravity, and that could include moon's influence on people. It's this technology that we're lagging in being able to measure things that are really important. Take this. Your cell phone in your pocket or on your desk or in your purse currently has 100,000 times more processing power of the computer that landed the man on the moon 50 years ago. Be prepared. Understanding quantum theory will better prepare you for the future, because we are going into a future that is unimaginable. Technology will grow exponentially from now on. So hold on, it's gonna be a wild ride. Thank you for watching, and join me again when Granny goes down the rabbit hole. Please like and subscribe.